Hi everyone, welcome back to Daily Data Engineering Shorts. In the last episode, we discussed how Delta Lake handles schema changes safely. Today, we are going to answer one of the most critical question: what happens when multiple jobs try to write the same Delta table at the same time? So the core problem is in distributed data systems, concurrent writes are unavoidable. Multiple pipelines, streaming jobs, or batch processes often target the same table simultaneously. So on the cloud object storage, there is no database lock manager, no coordinator, no shared memory. So without proper control, concurrent writes can override data, corrupt files, or leave the tables in an inconsistent state. So the question is, how does Delta Lake handles concurrent writes without using locks? So Delta Lake uses a strategy called optimistic concurrency control. Instead of blocking writers ahead of time, Delta Lake assumes that the conflicts are rare and allows jobs to proceed in parallel. So each write operation works on a snapshot of the table and prepare its changes independently. So nothing is logged in advance. Conflicts are detected only at the commit time. So how a write works in Delta Lake? When a job starts writing, it first reads the latest version of the table from the transaction log. It then writes new data files to the cloud storage. But at this stage, those files are not yet part of the table. So finally, the job attempts to commit its changes by creating the next version in the Delta transaction log. So if the table has not changed since the job started, the commit succeeds and become visible automatically. So how conflicts are detected? If another job has already committed changes to the table, and Delta Lake compares what the current job read with what has changed. So if the same data files or metadata are modified, the commit is rejected. So the job fails fast and can retry using the latest table version. This ensures that the only non-conflicting writes can be succeeded. So why fails writes are a feature? So in Delta Lake, a failed write is not a error in the system. It is a safety mechanism. Rejecting conflicting commits prevents silent data corruption and guarantees isolation. Writers either succeed completely or not at all. So preserving the ACID guarantees, which is atomicity, consistency, isolation, and durability, guarantees even on top of the cloud object storage. So this is how Delta Lake achieves a safe concurrency without locks, coordinators, or databases. So by combining the transaction log with the optimistic concurrency control. So that's it for this episode. In the next episode, we'll discuss how Delta Lake uh, enables time travel and data versioning. If this episode helped you understand distributed data systems better, like, share, subscribe, and follow this series for daily data engineering concepts. See you in next episode. Thank you.